All right, time to get started. We only have 40 minutes, so I'm going to pack whatever I can in, and hopefully I actually can have some more conversations with other people after the talk. The talk was titled With Security, but I decided after looking that I wanted to talk about all the things we need to talk about security and Clojure, especially when it comes to web apps. So what I'm not going to talk about before we get started is what the different attack vectors actually mean, how you attack them. So this is not Security 101 education. This is a list of problems that we need to solve. So I apologize if I go past some people, but please ask me afterwards. I probably won't have too much time for questions now, but please grab me afterwards if you want more explanation of what some of these concepts actually involve and that kind of thing. But we need to talk. We need to have a serious talk, you guys. Seriously. So there's a lot of things that have happened recently, and choices we made kind of got us here. A lot of them were good choices. But assumption is the mother of all mistakes. This is the thing. This is why you all have problems, because you assume things are the way they should be. And of course, necessity is the mother of invention. We had a language that propped up, and then we needed libraries, so we built stuff. We built it because we needed it. That was the point. I got to do this thing, so I'm going to build a library to do the thing. But then we assume that it was right because someone else built it. That's a common thing, right? It's there. It does what I need to do right now, so I'm just going to use it. And then we all are sitting here collectively, and this is the royal we. This is more than just this room. This is us as an industry, kind of wondering why we keep getting owned. I don't know if you guys have realized, but the rate of people getting compromised has gone up. It's like every week now. Somebody else is on the top of the news because they got hacked. It really isn't a matter of if, it's a matter of when. But there's something I need to get off my chest. This hurts me. This is painful to me. Clojure web apps are actually some of the worst I've seen in terms of security. This is like PHP level, like PHP no framework level security. And that's tough, right? So in my current job, I actually do audit applications, look for security holes. That's kind of my daily thing. I break stuff. But after looking at some Clojure web apps, it's been kind of an eye-opening experience. There's no saying defaults, but there's a systemic problem here, right? So this whole small composable abstractions, libraries over frameworks, the general idea that the Clojure community has brought actually has a kind of a fundamental disconnect when it comes to security, because everybody else thinks everybody else is doing the thing that they didn't do, right? There's no communication. There's no cohesion. That focus on what holds it together is really, really important, right? I mean, basically, we have bricks with no mortar. We have our building blocks, we have our bricks, but we don't have any way to really connect them and make them one thing, right? We made some attempts. There was a bunch of framework-like things that came out. One of them even got some traction and then kind of disappeared into a library, right? Basically, we rejected them and kind of harvested the internals for libraries. So we're back to this libraries thing. We're building web apps with libraries. And honestly, personally, I think that's a great choice. I like doing that. The problem is, we have things to build. We like options. We like choices. We like not being forced to fight frameworks, those kind of things. That stuff leads to other problems, right? So you have one problem or you have another problem or set of problems. We have to get better at building these things. So I have a list of things I brought to the table today. Kind of a state of the world, where we are, where we need to be, and what we can do to kind of get better at this stuff. So I'm going to talk about a few things today. And yes, it's a long list for a short amount of time, but I promise this is going to be a high-level thing. So I'm going to talk about password management, session management, authentication and authorization, cross-site request forgery, cross-site scripting, SQL injection, encryption, and secure headers. This is a kind of a grab bag of stuff, but it's some of the most common stuff that we need to deal with when we're building web apps. And yes, this gets a lot more complicated. There's a lot more things I haven't added here, but this is a list of kind of the basics, right? This brings us up to current standard web apps. So I'm going to do this from a distance. I'm not going to go super deep. And actually, I'm going to make a note here. If I missed your library, your framework, your thing, it's because it doesn't exist. And when I say that, I mean I built this talk by searching on Google and looking at the first page. There's a reason I did this. And that's because this is what everybody else does, right? I know some of the other things that are out there. I purposely left some of the things off of my slides, but that's because it didn't show up in Google, which means it doesn't actually exist. Real programmers use Google to write code. And honestly, in your day job, you're going to look at Clojure password management and type it into Google, and oh, great, I'm going to grab this thing and I'm going to use it. Right? This is how we write code. So yes, at the end of the talk, when you're thinking, oh yeah, but there's other library. No, it didn't come up in my Google search, so it doesn't count. It doesn't exist. So if you want to make it exist, that's another problem to solve, is make it exist on the first page. So without further ado, let's talk about passwords. We have a few options. Actually, there's more options here than there are for most of the other topics I'm going to talk about. The three that I see in common are one called crypto password, friend, which is a bigger framework, and lib-noir, which is kind of that harvested internals from noir, the framework. They all have kind of different options, so I'll detail those. Crypto password actually has adaptive hash family support. It's bcrypt, scrypt, pbkdf2, which is good choices. These are all solid choices, where we probably should be looking for when we're doing password storage. It's a small library. It's tiny. It's easily consumable. It's done well. And it has some fairly same defaults, with the exception of one thing. The pbkdf2 default number of rounds is actually a little bit short. Standards are now more 100,000 rounds plus to make pbkdf2 a same default. So it defaults to 20,000 rounds. It's not insecure. There's a balance there. But there's one thing I'm going to talk about that's in common across all of these libraries. And this is, I'm not going to go into detail because password management we could spend a whole talk on. There's no support for HMACing, the output of the hashes. And it also lacks migration options. How many of you have built an app but then have an old password management scheme you have to kind of ride on top of? And you might want to get out of that password management scheme, like plain text or just simple SHA hashes, those kind of things that really are incredibly weak. You have to have a migration path. So the library should really support SHA, the SHA family, even MD5, plain text, but offer that migration path. Up here's how I'm going to migrate based on the providers that I have. Friend. Friend is a bigger library. I'm going to talk about Friend a lot, actually. There's a lot of good stuff in Friend, and actually, I think Friend might be the glue that holds a lot of this stuff together. Sorry, Chaz. I'm putting it all on you right now. It's bcrypt. Bcrypt is the only option. That's nice. It's nice to have somebody say, this is what we're going to use, but it'd be nice to have options. It is part of a bigger library, like I said. And but like the other ones, it lacks a migration path, and there's no HMAC support. This is a common thing we're going to see across these. lib-noir is a SHA family plus bcrypt. Again, part of a bigger library, but it's not focused. lib-noir is kind of a generic, there's an everything library. So I don't know, give or take for me, I'd rather see lib-noir use a different password management library underneath, and I'll talk about that in a minute. But again, lacking options, lacking migration path, and no HMAC support. That HMAC support is actually super important. So we can create our hashes, or we can get our password storage values. But they're still going to get cracked. This is asymmetric warfare, right? They're always going to have more computing power than you do. And any attacker that knows this is going to be able to use it against you. It's a kind of a matter of time once your passwords get compromised. And it's a race between how long you can prevent somebody from actually cracking those passwords to actually being able to tell your users to reset their passwords and having them all do it. So adding that HMAC support to the end of the password chain actually increases the key space. So let's say HMAC SHA-256 increases that key space to the 256. That's a lot to crack, right? You're not gonna brute force that. So it's extra support, and it also adds a layer of defense. So somebody has to compromise your password database, and they have to get a hold of that HMAC key. So there's two separate attacks they have to pull off to get that. Now, if you put the HMAC key on the password device, server, then yeah, I mean that's kind of a problem. We want to separate those. But it adds extra layers of security, which is really good. So we have some stuff to do here to make this right. So honestly, like my preference is to use crypto password. Actually, to make it kind of a standard, right? We add the HMAC support and add the migration path, and now we have a nice library that does all of that stuff for us. And then we make it the default library underneath lib-noir and Friend and any of the other apps or frameworks that come out, libraries, I should say, libraries that come out, make crypto password kind of that community default. Right? We support one thing, and yes, there's different circumstances. Not everybody will be able to use it. There'll be some crazy thing you'll have to do on your own, but we want a majority, right? I would love to see this as the way forward underneath the different libraries. Sessions. This is something that is actually interesting to get right, and there's subtleties. We have basically really one thing for sessions, and that's ring. That's what we build everything on top of. So there's a lot of good things in ring. It actually supports all the stuff you'd want, mostly in session management, right? It supports the HTTP-only option, the secure option. There are multiple session storage options that are available. You can extend it easily. There's a lot of good stuff there. But it actually doesn't have persisted sessions, database back sessions, or memcache back sessions, anything like that. That doesn't actually, there's an in-memory store, which is kind of a caveat. But we're missing that piece. How many of you use cookie-only stores in your web apps? So you put a cookie on a browser, but you never put it in a database and check whether it's actually a valid cookie or not. There's a lot of liars in this room. I guarantee that. OK, so those of you that didn't raise your hand that are doing this, what you're opening yourself up to is session replay attacks. Anybody can copy that cookie off and present it back to you at a later time. It's a valid cookie. You created it. You can replay it anytime. So they can log out, and you can delete that cookie from their browser, but that cookie is still valid, right? It's never been invalidated by any mechanism at all, except for expiry, which is probably like 10 years in the future. So you want to back up by a database, or maybe not a database, maybe a cache of some sort, right? That's a really important thing to think about. So there's a couple things we want to do. One is documentation. The documentation for how to do this properly in Ring kind of exists, but you have to dig for it. We want to let people know, here's what you should do, here are the defaults, here are some sane options for security, right? Especially HTTP only. Ring doesn't do that by default. Now, I understand why, but there might be some things we can do here, right? Maybe friend actually sets the HTTP only cookie by default, because friend is specifically for authentication. And you really don't want JavaScript to mess with those cookies. And there may be some management layers, right? I think that's the kind of the takeaway there. But also, we want a library to persist sessions, right? Maybe we have a library that supports relational databases, some key value stores or caches, Atomic, that kind of thing, right? Back it with a store and validate the cookies, so you don't expose yourself to that replay attack. This is actually a really common thing. Right? Somebody sits in a Wi-Fi shop, steals a session, and on off we go. We'll talk about SSL later, and also kind of some other things around encryption. Authentication. So this is, again, I'm going to keep coming back to kind of one thing, right? I'm going to keep coming back to friend. I looked for a lot of different stuff. There are other things that are listed. The last contribution, last check-in to GitHub or wherever they were at was like a year, 2 years ago, right? They're unmaintained. Friend is the only one that I could find on that first page of Google searches that's actually being maintained or actively discussed. So it has basic authentication strategies. I don't mean basic auth. I mean the basic realm of things you would want to do with authentication. It has some authorization stuff we'll talk about in a minute. It has the password management support underneath it. It's pretty easy to integrate. If you're using the Composure stack, super easy to add in. There's a lot of good things that come around Friend. I've had some trouble outside of the Ring layer with it, but again, it's built on top of that for a reason. But when you got the more complicated authentication strategies, I mean, this is something that's really hard as a library author, right? You have your own kind of world you need to authenticate. Friend shouldn't support everything. It should support the basic ideas, and then you can build on top of them. So it's really about abstractions. So what do we do here, right? It'd be nice to have more options, but why don't we make the one we have better, right? Let's support Friend. Let's contribute to it. Let's try to make it better. I think that's the takeaway here. And actually, don't roll your own library if you can help it. Auth might seem easy, but there's a lot of things you can get wrong. There's subtle things you can get wrong. So it's something you don't want to roll your own if you can help it. Now, if you're stuck with a legacy system, something you have to attach to, there's nothing you can do about it. But try to do this Friend if you can, and try to help Friend. Try to make Friend grow. Then again, authorization. Same thing, right? Again, we're going to go right back to Friend. The authorization is built into Friend as well, but super, super important. And this is something you'll see requested often, probably on the Friend mailing list, is it's a library to build role-based access controls, right? The idea is you build your roles and rights with Friend. Friend doesn't provide everything out of the box for you, and nor should it, right? You still need to build the roles and rights that actually apply to your system. There are 0 good defaults here. There will never be a good default that you can use out of the box for your web app out of a role-based authentication framework. It doesn't exist. And if it is, it's probably not going to work right for you. This is something you have to build. Friend can give you the tools to build it, but you have to build it. This is something that becomes good planning, good strategy, execution by you, not by a library. Cross-site request forgery. I call it the confused deputy problem. Basically, allowing somebody to use your current session in your browser on your behalf via some evil scripts. So we kind of have one answer here, too. It's called ring anti-forgery. It's a middleware you slap in. It does what you want. You should use it. Unless you have an API, right? Obviously, be careful about this. Don't slap this in your middleware for everything and then expose it on your API, because nothing will work. A machine will submit, and it won't submit the CSRF token, and then everything will start failing. So be very careful when you do this, when you expose APIs, because you'll block everybody from actually submitting API requests properly. So there's a caveat there. Make sure you have two different sets of routes. And the user-facing routes have the CSRF token. The machine-focused routes don't. All right. So now we're going to get to the ones that have problems. Really, really big problems. Cross-site scripting. This is a tough one to solve. There's kind of a problem here, right? The question of what do we have, this is insane, right? Because it's not about what we have for cross-site scripting protection. It's about how many freaking template libraries are out there. I mean, I just stopped counting, right? How many template libraries exist today just for use in Clojure? Anybody know? It's more than a dozen. Yeah, it's more than a dozen for sure, right? So let's just talk about the problem for a minute, right? There's things we want to do. The things that are essential to protecting us from cross-site scripting are being able to escape HTML tags on the way out, always on the way out. Allowing some HTML to be presented. If you have a WYSIWYG editor or you have some kind of markup that you support in stylistically for your users, you want that to be able to be presented without the bad stuff, right? You want that control over what gets escaped and what doesn't, so kind of finer-grained controls. And finally, you want to have a good default. You want to default to always escaping things, and then have users of your library turn that off when it's necessary. But be able to turn it off with controls, right? Turn it off and say, well, actually, I want to turn it off, but I really only want to present the bold tag and the unordered list tag and that kind of thing. You kind of give a white list of tags you actually want it to present, and everything else gets stripped out too. So it's a default, and escaping everything is super important. So now you think about that engine of choice, whatever you're using, right? It could just be HTML with some stuff inserted into it. It could be Hiccup, it could be Haml, it could be Mustache, or any of them, right? Think about what it provides, and now think, does that template library you're using use all of those things? Does it provide you with those things? In most cases, it doesn't, right? I know Hiccup doesn't. Hiccup has an escape HTML function, but it's pretty tiny. Mustache does provide you with some default escaping, but there's not a lot of control over it. There's a lot of things you need to think about here. So what do we do? This is a tricky one, right? There's definitely one answer here. We just got to stop. It's HTML. We're going to emit it. It's going to be fine. Let's move on, right? I've been on a project that had 4 different HTML template languages in it, and they kept fighting over which one. And one day, somebody spends an entire week, oh, I've converted Mustache to Haml. And then somebody else goes, well, I converted Haml to Mustache. And you're like, stop. Please just stop. Pick one. Just pick one, right? None of them are going to be perfect. It's HTML. Find one that works. Find one that you guys can all tolerate collectively as a team, and move towards it. And then figure out a way to kind of just deal with it. When that next one comes out, it's like, oh, that's shiny and pretty. It's just as bad as all the rest of them. It's not any better, I promise you. But just choose one. Choose one that has the most supported options that your team can really work with, and then find a way to add the rest of those options, right? Find a way to do whitelist sanitization, that kind of stuff. It's not a hard problem to solve. Stripping those tags is not terribly complicated. You can look for ideas and implementation you can mimic from other frameworks out there. There might be some that actually have everything. But then again, you want to find one that works for your team, too. But as you're choosing those templates, when you're picking one, evaluate cross-site scripting protection as part of that library, right? Don't just say, well, this is the prettiest one. Also make sure it's the most useful. The point is, if it's no more useful than standard HTML, what's the point? You haven't solved any problem at all. So make sure it's useful. so I was going to talk about SQL injection, and then I realized there's a bigger problem here. There's no SQL injection and other kinds of things that come around there too, right? Just like we had SQL injection, all of these other databases are injectable as well. And that becomes kind of a bigger problem. But again, this is kind of the same problem. When you think about what we have a set of problems. The same problem, actually, we have with HTML template libraries. How many databases do we have? How many database vendors are sitting in my talk right now? I see at least one. There's 2, 3. Yeah, so there's 3 database vendors sitting in the room right now, right? There's a big one down the street also. Big one down the street here. But that's the problem, right? We have a lot of options. We have a lot of things we have to think about. Injection is a scope to the database we're using, but there are so many different databases that we have available to us. But let's take a moment and be honest about the state of relational database support in Clojure in general. Let's think about that for a minute. Let's come to terms with what we have. Now, what I'm saying is that it's not bad, right? There's a good solid library. Java.jdbc has all the fundamentals you need to do the thing you need, right? It's there. But there's some things we need to think about, right? One is supporting it, making it better, right? Anytime I've heard somebody complain about, oh yeah, Java.jdbc doesn't do this, well then fix it, right? You guys have the power to fix it. We can do this. We can make it better, right? But there's that abstraction layer, right? We're missing that abstraction layer. SQL Korma came out, and it had a lot of promise. And it was there, and everybody said, great, there's a better abstraction, I'm going to use it. And then it went, oh, it's not ready yet, right? Really close, but it's not ready yet. And then it kind of just didn't really evolve. It kind of teetered off. And now there's been some efforts to bring it back, but that abstraction level is missing. And what I mean, seriously what I mean is not an ORM, right? I don't mean ORMs. I just mean just a higher level of abstraction over that raw Java.jdbc layer. I'm definitely not proposing we have our ORMs or we go to Hibernate or we go to that kind of stuff. That is not my advice. That's a whole different set of problems when you go there. I will follow Rich's lead on this one. OK, so encryption. How many of you have to deal with encryption on a daily basis? How many of you are happy about the fact that you have to deal with encryption on a daily basis? All right, so a couple people. Maybe I'll have some takers here. So this is interesting, because we don't have anything here. There's no libraries that do crypto for Clojure. And actually, we have something just a little bit different. We have something worse, actually. We have JCA, and we have Bouncy Castle. The Java crypto architecture and Bouncy Castle. They're libraries for crypto. They're Java libraries. So you have to understand crypto to use them. These are not friendly libraries. These are libraries you use when you actually understand the mechanics of crypto. And unless you understand the mechanics of crypto, you cannot use them effectively, period. This is an interesting kind of side effect, right? Without any libraries and with very base libraries that require knowledge of crypto, we need to ask for help. Stop. If you're implementing your own crypto system around these things and it hasn't been implemented by somebody else that you can trust, stop and ask for help. Find somebody to help you. You will get this wrong, I promise. Every time I see a crypto system that's been built from scratch by somebody who really doesn't understand the mechanics, there's some piece of it is wrong. It's misunderstood. I will give a challenge. I will give a copy of Programming Clojure to anybody who can find me and tell me how to properly implement encryption via JCA and Bouncy Castle. Come find me, set aside an hour. I will buy you beers, we will talk about it. Because what I really want to do is then team up and go build a library for Clojure that we can all use. That's just encrypt and decrypt, the things we really want to do. So I actually do want to solve this problem, but I also want to team up with you. We need a better answer to this. Now, there might be some great Java libraries out there that you can purchase or that have already been built that you can use. But the defaults that we get with the language and that kind of the other default of Bouncy Castle isn't good enough. Because the problem is we're left with crypto systems that just are broken, fundamentally. And there's SSL. Now, SSL is not a library concern. This is something we're going to do at a higher level, our web server levels. But I want to talk about it for a minute, because we're not using it. For some reason, we're just not using it. Every time I go to a login page, it's HTTP. It's missing the S. Sessions are sent over HTTP. All that stuff I talked about, persistent sessions and stuff, you can make the problem a little bit better. How many of you heard of Firesheep when Firesheep came out? Right? What does Firesheep do? It makes it fun. That's right. So that's the point, right? It steals sessions. You open it up, and it just takes everybody's sessions on the public Wi-Fi. So if you open it up right here, right now, I guarantee you'll get some sessions. Don't do that. But you could, if you wanted to do that. Let's say on a public Wi-Fi network. Public Wi-Fi networks are fun. All kinds of things are interesting around that. But as you're making an app, you owe it to your users to do this. Buy a cert and set it up. Now, there are lots of things to do with setting up SSL certs, but they're not Clojure libraries, and I'm going to skip them. So if you want to talk about them, please come find me, and I'd be happy to give you some advice. But there's no real library support other than making sure that when you have SSL enabled, that those cookies are sent over SSL. And that's a secure flag you set on the ring session. Something you could just set manually, or something you could do at the higher level inside of friend. Last, we have secure headers. It's a collection of stuff. Collections of things that you want to send down as part of your response. Things like the X-frame options, save origin or deny to prevent the clickjacking attacks. Cross-site scripting protection, which is kind of a marginally supported header across different browsers, but it's focused just at cross-site scripting protection. Content type options is important because you can do things like no sniff. CSP, I'm not talking about async, but I'm talking about content security policy. Actually, a larger group of stuff, really more focused on cross-site scripting, but other kind of problems. CSP is a very hard thing to roll out. It takes a lot of time, a lot of tuning, a lot of testing. CSP is a big endeavor. So you want to be able to support this, but you also need to do a lot of work to get it right. But finally, HTTP strict transport security, or HSTS. Make sure that you're going to keep going over SSL. Right? It's an attack that's going to force you to use SSL. If a site has HTTP and HTTPS options, it's going to make sure you're always folding back to that HTTPS option. So you can't be man-in-the-middle redirected, those kind of things. It's kind of a better principle to have. These are kind of the most useful. There are some other ones that are around that you want to take a look at. These are kind of the generally most useful ones you want to think about. So what do we have in this department? I guess we don't really have much, right? There's nobody that's going to control these for us. You can just set them in ring in most of the cases. You tell ring, I want these to be spit out, and out it comes. It's not a difficult problem to solve, but it'd be really nice to have something that manages and controls them from a higher level, right? Being able to say, yes, I want to turn on no sniff. I want to turn on clickjacking protection. We'll call it what it is, and then it'll set the right header out. So it's an English problem we're solving, but also just a simple management thing. There's actually a Ruby gem that I want to use as an example. Yes, I know. But it's a good example. The guys at Twitter made it. And it does these things for you in Ruby on Rails. And actually, I think it was good enough that I think the latest version of Ruby, they actually just adopted those defaults into the framework. So if you want to take a look at that as an example, it's got a bunch of really good stuff in there. This is what we should be doing. This is what we should be sending down. All right, so wrapping up. Composable abstractions, good. They're awesome. I love building things this way. I really, truly think this is the right thing to do. But we need to focus on the mortar. We need to figure out who's doing what and stop making assumptions. We need to force ourselves to examine the system as a whole and not the libraries, and find a way to fill those cracks. We want to fix the libraries. We need to fix the libraries that are there. We need to make new ones that don't exist. And we need to agree on some standard defaults as a community. We need to stop being so fractal when it comes to basics, right? We can get really, really fractal when it comes to esoteric stuff. When it comes to basics, we have to come together as a community and make something that we all agree on. Security is security. There's some things you just do. It's just like having an HTTP server, right? We standardize on Ring for the most part because you got to serve HTTP, right? We got to do the same kind of thing for security. We want that same kind of bring it all together. We do this thing. We do this thing well, and that's really important, right? Yes, your app is a special snowflake. I'm not trying to tell you it's not unique. You will do different things. You will do special things. You will do crazy things in the name of whatever you're doing. But let's not deviate from the proper security practices, right? This is not the place to deviate. This is not the place to be special and unique. If you're building a security-focused company, you know everything I just said anyways, and you're doing your own thing. But if you're not, right, this is not the place to be special and unique. This is the place to be solid and focused, right? There is one thing that will always be true. No matter what you do, you will be attacked and you will be compromised. This happens. This is a truth. This is a tautology, right? This will happen. Do not be proud. Do not think you're better than everybody else. It's just going to happen. Let's make sure it doesn't happen from some script that's running around the internet. Let's try to raise the bar just a little bit higher. That's the big thing here. We got to raise the bar a little bit. When you have a complicated app, it's going to be complicated to secure in some cases. So make it simple. Remove the complexity. When you add the complexity, you make it harder to secure. Make it simple. Focus on design. Focus on good architecture. That's what makes secure systems. Security doesn't make secure systems. Good design makes secure systems. So focus on the architecture, build the right things, and focus on the things that matter. Right? Don't deviate from these security ideas. They're really, really, really important. And our track record isn't so good. So let's raise the bar. Let's make Clojure better for web security. For web development in general, well, let's make Clojure a better place for web security. So please come find me. I'm only here today, unfortunately. I have to take off, but come find me. Let's talk about security. If we want to write a library, come find me. Let's talk about what we do, how we fix it. If you're an author of one of the libraries I mentioned here, let's get a pull request in or something today and make it work. So I have a few minutes for questions. Fire away.